On How It's Made, we usually stick to the show's title and show you how products are manufactured. But this next segment is about special effects makeup, the kind that makeup artists use on theater and movie actors. So in this case, we'll show you how it's made, but we'll also show you how it's applied. Watch as this special effects makeup artist works his magic to transform this 28-year-old woman into a senior citizen. After gelling her hair flat, he glues on a bald cap using a theatrical adhesive called spirit gum. He protects her eyebrows and eyelashes with petroleum jelly, then covers her face in alginate, a material for taking dental impressions. Then he applies wet plaster bandages. After 25 minutes, the materials harden into a mask. Now he lines it with plaster. In a half hour, the plaster hardens into a perfect replica of the woman's face. Like putting non-stick spray on a baking pan, he coats the model in a release agent. Then, using professional-grade plasticine, he begins to sculpt an elderly face. He smooths out the wrinkles with strong rubbing alcohol so they'll look realistic. He uses a bumpy rubber pad to give the skin an aged orange peel texture. The finished sculpture sits in water for 2 to 3 hours. This activates the release agent, detaching the plasticine from the plaster underneath. Now the artist carefully cuts the sculpture into sections. The number of pieces varies with the size and complexity of the mask. Now he can finally start producing the mold he'll use to cast the old lady face mask. First, he takes a thin plaster impression of each piece. Then he coats the impression in plaster to make the positive half of the mold. Once it hardens, he applies the plasticine piece to space the depth of the mold cavity. Then he coats that in plaster to create the negative half of the mold. When that hardens, he applies release agent to both mold cavities, pours in hot gelatin, then closes the mold. In a half hour, the gelatin hardens into a flexible replica of that particular piece of the plasticine sculpture. He then implants synthetic hairs to create eyebrows. Now, using surgical glue, he begins to apply the pieces, called prosthetics. He starts with the largest face piece first. It includes the nose, cheeks, neck, and upper lip. He cuts a hole in the chin area so that he can apply the chin piece. Now, the lower lip. He cuts off the excess, then glues the edges of the chin piece to the large face piece. Now for the forehead. Again, he applies glue along the edges to connect it to the rest. To age the eyes, he uses contact lenses. They create a ring around the iris, a typical feature of elderly eyes. Using tweezers, he applies eye bags, again gluing the edges to the rest of the mask. And finally, some wrinkly eyelids. With the mask fully assembled, it's makeup time. Using a toothbrush, the artist sprays it unevenly over the mask, then smudges it with his fingers. This technique creates a realistic look because the human face, aged skin especially, has color variations. Using a very thin brush, he accentuates some wrinkles by creating depth with a darker color. Now, some freckles and age spots. And a gray wig. And finally, just a bit of lip color because lips dull with age. All this takes an experienced makeup artist about a month of work, and such expertise doesn't come cheap. A major transformation like this for stage or screen can cost up to $10,000.
Tattooing dates at least as far back as the Bronze Age. A 5,000-year-old body found in a European glacier had several tattoos on his skin. Archaeologists have even uncovered what they believe are Stone Age tattooing instruments, sharp bone needles and clay discs containing mineral pigments. Walk into a tattoo parlor and the vast selection of elaborate designs will astound you. Once you make your choice, the tattoo artist traces the image. Next, he places the traced image on carbon paper and retraces the lines. This creates a carbon outline of the tattoo on the reverse side. The artist will use this blueprint, as it's called, as his guide. He cleans the customer's skin, then firmly presses on the blueprint. The carbon image transfers easily because the skin is damp. Now it's time to construct the needles. Most tattoos require 2 needles, one to make the outline of the image, the other to shade and color it in. Each needle is made up of as many as 20 smaller needles. The artist aligns these small needles in a jig, then solders them together onto one end of a steel rod. There's an eye on the other end. The number of small needles in a needle depends on the tattoo design, how thick its lines are, how big its colored areas are. The finished needles go into an autoclave to be sterilized. That takes 20 minutes at precisely 170 degrees Celsius. The tattoo artist uses that time to assemble the tattoo gun. After cleaning the frame with rubbing alcohol, he installs the motor called the coil. When an electric current runs through the coil, it oscillates the needle at up to 50 times per second. Once the 2 needles are sterilized, he takes the one for outlining, called the liner, and slides it into the tattoo gun. He hooks the eye on the other end onto the spring. As the spring moves back and forth, it moves the needle up and down. The tattoo artist stops and starts it with a foot pedal, like a sewing machine. Time to tattoo. He turns on the power supply to 10 volts and dabs the needle in the ink cap. The gun sucks up the ink. Some petroleum jelly on the skin helps the needle glide more easily. He begins by tracing the lines of the blueprint. The needle punctures the skin at a rate of up to 3,000 times per minute, injecting microparticles of ink which intermingle with the cells of the dermis, the skin's second layer. The artist continually wipes away the excess ink to keep his work area clean. After finishing the outline, he reapplies petroleum jelly. This seals the pores of the skin and prevents bleeding. Then he changes to the other needle and begins shading and coloring the image with a back and forth movement. He applies one color at a time, overlapping them to ensure thorough and even coverage. The needle can penetrate from 1 to 4 millimeters, and a good tattoo artist knows just how deep to go to create the different parts of the image. For example, he has to inject the outline the deepest, but going too deep can tear the skin and cause excessive pain and bleeding. But not going deep enough misses the dermis and leaves marks after healing. The cells of the dermis are remarkably stable, so tattoos last a lifetime. This tattoo has taken approximately 45 minutes to do from start to finish. The area will dry and scab over. Then, the scab will fall off, and this body art will be ready for exhibition.
Flat puzzles are well known by everyone, but 3D puzzles present a different challenge. These three-dimensional puzzles are first conceived with computer software. Good blades are needed to cut puzzle pieces. Here are the blades for the master die, which will cut out printed sheets of different models. This rubber will be used to eject the die. The master cutting die is unique to each puzzle. It is the specific pattern used to make the puzzle. They measure it meticulously to obtain a perfect register. It's imperative that the die not move during the cutting, otherwise the pieces would be cut at the wrong points, so they very firmly secure it in place. The carbon of the die is positioned. It's somewhat like printing the master. Alignment is again verified, a highly important step which assures the quality of the final product. Finally, they install this large metallic plate, which is the cutting base. It will be on this surface that the master die will strike. Once measurements are finished, the drawer of the die is slid into place. This press cuts the pattern seen on the puzzle. Here's how it works. The sheets, or printed cardboards, go into the drawer one by one, where they are cut according to the master model. We clearly see the press making the cut in the puzzle sheet. The cut sheets pile up on one another. And at this checkpoint, they verify the precision of the cut. They make sure that every piece is correctly shaped. Now they go to the foam support of the puzzle. This guillotine is used to cut the polyethylene sheets onto which they will glue the cut images. Foam sheets are inserted into this laminator, heated to 232 degrees centigrade. The sheet with the design on it is glued onto the foam with a thermosetting adhesive. Now they glue the printed sheet onto the foam sheet. Once the adhesion is finished, the puzzles are stacked on one another, and they proceed to the unbuckling operation. By pulling, they remove the surplus cuttings. The same design is printed several times on a sheet, so they must separate each puzzle. This step is called the reduction of the models. Now the pieces have to be separated. This decorticator handles this task and sends the pieces down a chute. Packing cartons arrive already made up, and the puzzle pieces are placed in their boxes. No less than 15,000 puzzles are produced here each day. Since it began operations, the company has created more than 300 different puzzle models, from quite simple ones to much more complex designs. The largest of them contain a total of 3,146 pieces. And you need real patience for this one.
What is biophotonics? Well, bio is short for biology. Photonics is the physics of light. Biophotonics uses sophisticated imaging and other sensitive optical instruments to conduct biomedical research. Biophotonics has a range of uses, from medical diagnosis to drug screening. In the golden years of animated film, teams of animators would draw every single illustration by hand. Today, they do much of their work by computer. But that doesn't mean it's any less artistic. It all starts with a screenplay, a script containing not just dialogue, but also physical descriptions of the characters and background scenery. The art director begins creating the characters. He draws in pencil. When he's finished, he traces the drawing in felt pen. Then he erases the pencil marks. He adds shadowing to create relief. Once he's drawn all the characters, he starts the backgrounds. And then the objects that appear in the backgrounds. The storyboard artist blocks out the film on paper, drawing by drawing. The production team will follow this storyboard the way a dressmaker follows a pattern. They blow up the drawings, scan them into the computer, then play them back in chronological order. This creates what's called an animatic, a two-dimensional version of the film minus the animation. Should the director now decide to change, say, a ground-level view of the street to an aerial view, he has the artist redraw the street from that new angle. Meanwhile, the animators work on bringing the characters to life. Using specialized software, they build a skeleton to fit inside the character's body. When they move the skeleton, the software makes the body move with it. They make the characters three-dimensional using a technique called wireframe animation. First, they build the shape of the character using a wire structure. Then they add color and clothing. They further refine the character by modifying facial features, by adding texture, and by shadowing. They use specialized software to synchronize the character's mouth with the dialogue. The technician works syllable by syllable, picking the mouth movement that matches each sound. It's a painstaking process that takes many months. Another animator applies the lighting effects. Lighting is as important in an animated cartoon as it is in a movie with real people. It creates relief, making everything look more realistic. The animators cut and paste the characters and objects onto the backgrounds. With the characters' movements programmed into the computer, the animators turn the two-dimensional stills version of the film into a three-dimensional animation, essentially a rough cut of the film. Meanwhile, in the studio, the soundtrack takes shape. Actors record the characters' dialogue. The sound technician weaves together the voices, the music, and the sound effects using specially designed software. They sync the soundtrack to the rough cut of the film. Then they refine the rough cut, playing with colors and textures and smoothing out the characters' movements. After a full year's work and more than 42,000 drawings, this 24-minute computer-animated film is finally finished.